Hi, this is Rick. Let's do Chapter 4 on making decisions. Making decisions is one thing that the computer really likes to do. It gets a chuckle out of helping you decide things. Of course, you have to program it to tell it what decisions to make in certain cases. So remember that this presentation in nowhere even begins to supplant your book. You need that book. In fact, it's best if you actually go through the book at the same time you're watching this, and then feel free to stop the video so that you can go in there and read a little bit more detail if you need to. So the chapter actually starts off with these objectives. And then next time, in Part B, we'll actually cover these objectives. So let's get started. Introduction to decision structures. Basically, a decision structure is a program that allows you to perform actions only under certain conditions. So we have to ask ourselves, if this is true, then we're going to go do that. There are different types of decisions, and they include if, then, and if, which is like a single alternative. If it happens, we're going to do it. If it doesn't happen, we're not going to do anything. If, then, else, and if, which is also called a dual alternative. That's kind of like, if it happens, we're going to do this. If it doesn't happen, we're going to do this. And then you've got case structure, which we'll talk about. That's when you have things like, if you're a sophomore, you're going to do this. If you're a junior, you're going to do this. If you're a freshman, you're going to do this. It doesn't have a yes or no answer or a true and false answer. It's actually got many different possible answers. So this is an if statement. An if statement is action that only occurs if the decision is true. Okay, so if the condition is true, then, notice the words in red, if then, we're going to do something, maybe two things, and then we're going to stop making the decision. Now, what if it's not true? Well, then we don't do anything. Whenever we represent a decision or a condition, we represent it with a diamond, and we write our little condition inside that diamond. So here's a good example of one. So we come down and we say, if it's cold outside, if that's true, then we wear a coat, and then we end the if. Now, you'll notice if we come down and it's cold outside and it's false, we just go straight through. We don't even bother going to the closet and looking at our jackets. So the idea of this being a single alternative structure is pretty evident. So there's our if, then statement, and our end if. So turn to page 127 and trace the logic in figure 2. Then turn to page 128 and trace the logic in figure 3. In order to actually make a comparison or find out if something is true or false, we need what are called relational operators. And they actually determine the relationship between the two values. So within a Boolean condition, which means it's either true or false, you have all these things. And we're going to look at each one of these. Now, just reading from left to right, I would say that x is greater than y. Remember that little symbol that you had back in 6th grade? Well, we get to use it now. And the second expression says x is less than y. The third one says x is greater than or equal to y. And there's x less than y again. And then we've got x less than or equal to y. And then we've got x compared to y. That's what the double equals mean. And then we've got x not equal to y. So those are the readings of those expressions. And this is a table that comes out of your book that you can look at and explains each one of those things. So we're going to introduce 3 new operators at this point. We're going to say greater than or equal to and less than or equal to. So an example of that might be the value of your car or car value variable is greater than or equal to 5,000. Car value may be less than or equal to 25,000. Notice that those numbers are represented without a dollar sign, without commas and .00s after them. We're just going to be real simple with them here. The double equals is a comparator. So we say, is your birthday equal to the function called today? So we take today's date and we compare it with your birthday, which you entered. We can also say that birthday equals today, And that's not the same thing. In the first expression, we're saying, okay, we've calculated what today is, and we're going to compare that with your birthday. In the second expression, we say, we've calculated what today is, and we're going to put it in the variable called birthday. Look at the warning on page 130, please. This one is called a bang equals, and when you go to the cocktail party and standing there with your martini in your hand, you want to say bang. Okay, that means exclamation point. Don't say exclamation point. That sounds weird. Basically, we say car value not equal to 0, hopefully. Go to page 134 and trace the logic in figure 7. Now we have a little bit more complex statement. We're going to say if, then, else, and if. So we're going to provide for the condition not being true. So it executes if its Boolean value is expressed as true or another group of its Boolean expression is false. So here we go. We take a look at this and we can kind of trace it down. There's our if statement. Our if says if temperature is less than 40, then, because that's true, if it's less than 40, let's say it's 35. So if it's true, then we go to the right, and we always go to the right. In this case, in this class, we're always going to go to the right for true. Then there's our statement, display a little cold, isn't it? And then there's our end if. So tracing that down, if, then, statement, end if. Well, what if it's 45? Well, now our condition is not true. It's false. So we would say else, and there's our statement, and it would fall through to the end if. So we've got something happening if it's greater than 40 and something if it's less than 40. Dual alternative decision structures. It's an if, the condition, and then we put our statements in there, what we want it to do, and then we've got that else. That's our little congratulations. If it's false, you're going to do this. There are statements, and then we always have an end if at the bottom. So let's give an example of that. If the temperature is less than 40, then, so we're assuming that if it's 35 and that condition is true, we're going to do what follows the then. So there's our two statements, and it'll execute there. Now, if it executes the then, it automatically drops out to the end if. It does not go to the else. If it's greater than 40, then it doesn't do the then, it does the else. So if temperature is, let's say, 45, the condition is false, it's going to go down to the else and run our statements down there. When it gets finished with either the then or the else, and it only runs once, then we're going to end if. So here are our statements that will get run if it's true. Here are our statements that are going to run if it's false. Turn to page 139 and trace the logic in figure 11. Now, it's possible to actually use Boolean and an if-then-else statement to test strings. So let's say that I've got a program, and that program I've pre-programmed to have a password, and that password has got to be Prospero, all lowercase. Take a look at line 10. There's our if statement. So if password variable is compared to Prospero, and it's true, then display password accepted. If it's not, if the password variable is compared to Prospero and it's not true, then display the else, which would display sorry, that is not the correct password. So can you trace the if statement from line 10 to line 14? There are several things that we need to consider when we compare strings. First of all, strings can be compared to other strings. So we can say if name1 variable equals or compares to name2 variable. Now, don't forget, strings can also be compared to literals. So at this point we can say our month function, if our month function is not equal to October, so month was calculated by the computer, and there is their not equal to, and October's in quotes because that's a string. So we're going to say month is not equal to October, and then something would happen. Remember that they're case sensitive. So if I spelled October with a lowercase, it's not going to find it. You can also determine whether one string is greater than the other because they're all numbers. So let's take a look at that. Here's our ASCII chart. And because computers can't read letters, they read numbers. Letters have a numeric alternative. So, for example, if you go to this particular website, you'll find the table that I'm going to display. This is called an ASCII table. And you'll notice that an uppercase A has a decimal equivalent number of 65. Now, take a look across the column and you'll notice that a lowercase a has a decimal equivalent of 97. So we can say that the uppercase a has a lower value than the lowercase a. So if we were going to sort, we'd say sort from least to most, and the uppercase a would sort first at the top of the list, and the lowercase a would then come underneath that somewhere. Okay, go to the checkpoint on page 145 and make sure that you understand what we've done. And then turn to page 165 and do review questions 1 through 9.